In section 1.3, we're going to be measuring and constructing angles. Now, let's look at this drawing of the surveyor. This tool that the surveyor is using is called a transit. You may have seen them at a construction site, or as you're driving with your parents in the car, you might see them on the side of the road. The purpose of this transit is it's a tool for measuring angles. It consists of a telescope that swivels horizontally and vertically. Using a transit, a surveyor can use distance of points, 2 points, and they actually can measure the angle formed by the location and the 2 points that it's looking at. So using distance and angles is what the surveyor does. We're going to start off with 2 vocab words. An angle is a figure formed by 2 rays, or sides, with a common endpoint called the vertex. So the vertex is that common endpoint where the 2 rays come together. So let's draw an angle here. There's one ray. There's another ray. We're going to call this endpoint R. That's called the vertex. I'm going to put 2 other points on the ray, and let's call them S and T. Now the next 2 definitions are fairly easy and straightforward, but we still have to go over them. The interior of an angle is the set of all points between the sides of the angle, and the exterior is the set of all points outside the angle. So for example, this would be the interior of an angle, all of this. And the outside of the angle would be called the exterior. So this is all the exterior of the angle. Now, naming an angle. This is very, very important. You can name an angle in several ways. You can name it by its vertex. So if we're looking at the angle over here, I can name by the vertex. I can name it angle R. I can also name it by using a point on each ray and the vertex, but the vertex has to be the middle point. So I can name this angle by using SRT or TRS. The R has to be the middle letter though, since it's the vertex. So SRT or angle TRS. I can also using it, like if I named it by a number, which is angle 1. Now, if it was an angle 1, then I'd have to put a 1 right here. Let me do it in blue so it's easier to see. 1 right there. There's a 1 right there. So we'd have to put a 1 within the angle, and we could call it angle 1. Example 1. A surveyor recorded the angles formed by a transit, which is point T, and 3 distant points Q, R, and S. Name 3 of the angles. Point T right here is our transit. So we have 3 angles. Now, I'm hoping you can see them. We're going to start with the big angle. The big angle, we cannot call it angle T. Remember how we just said that we can use the naming of an angle by naming its vertex. The problem is, here you can't say angle T, because angle T could be the vertex of 3 angles. Therefore, we don't know which angle we're talking about. Angle T, the vertex, can only be named if it's only used for 1 angle. So we're going to have to use 3 points. So we can say angle QTS. Now we don't have to say the other one. The other one will be STQ. But QTS or STQ, you would not write both of them. If we're naming an angle, you're only going to use the name of 1 angle. So if you put both of them down, you're naming it twice, which we don't want. The next angle, let's do green here. That angle we can name by saying angle QTR or angle RTQ, but that clearly shows that we can name it angle 1. See, there's a 1 right here, so that's angle 1. The next one can be, for example, RTS or STR, but we can also name it by saying angle 2. Any one of those would be an acceptable answer. So there's multiple ways to name one at a certain angle. The measure of an angle is usually given in degrees. Therefore, that's our next vocab word, is the measure of an angle. Since there are 360 degrees in a circle, 1 degree would represent 1/360th of a circle. Now on page 20, there is a postulate that's called the protractor postulate. A protractor is used to measure angles. All it says is this. You don't need to write this one down. But a protractor postulate says that if you have a line and you have a point on that line, all rays that can be drawn from O or point O can be put into a 1-to-1 correspondent with the real numbers from 0 to 180. So all it says is this. It sounds confusing, it's not. If you have a line and there's a point O, if you put that protractor on there, you can name or use all of the rays that you can draw from 0 to 180 because a line is 180 degrees. Therefore, you can make angles anywhere using a protractor on that line AB. The next thing your book covers are the 4 angles that you've talked about in prior years. So we're not going to go over this, but here are all 4 angles: acute, right, obtuse, and straight. It's on page 21 if you need to review it, but you need to know what an acute angle is, a right angle, an obtuse angle, and a straight angle. The next vocab word is congruent angles. Congruent angles are angles that have the same measure. They're equal. So once again, this is where you have to be careful in your usage of symbols and measurements and etc., etc. So first off, I'm going to draw 2 congruent angles. All right, so let's look at what I've drawn. I have 2 angles. They're congruent. Now, obviously, they might not look like it, but we're going to say that they're congruent. The red arcs represent that they are congruent. Just like how we use tick marks with segments, we can use arc marks to show that those 2 angles are congruent. So remember, measures or distances are equal. The actual segments or angles of something are congruent. So in the diagram, this is how we say the measure. The measure, we use a lowercase m. The measure of angle ABC, ABC right here, ABC, is equal to the measure of angle DEF. So we're saying that the numbers, the measurements are equal. So then you can state that angle ABC is congruent to angle DEF. So once again, you would read this as angle ABC is congruent to angle DEF. The next section we are going to skip over. It is in your book. However, we have to do it in class because we are going to construct congruent angles. So we have to actually use a compass, which I will show you how to do that in class. The angle addition postulate is postulate number 132. Here's what it states. If S is the interior of angle PQR, then the measure of angle PQS plus the measure of angle SQR would give us the measure of angle PQR. And you're like, I have no clue what that even means. Here's what it's saying. S, if S, that means point. So we have an angle. This angle, it says is PQR. So we're going to name it PQR. It says S is in the interior. That's a point. So we have to have a point S. That means we have an angle here, or a ray, and that cuts the angle into 2 other angles. Here's what it states. Now I'm going to actually shade this part red and shade this part blue. What it states is this. If you have, let me actually color code this, PQS. So blue is PQS, that's this. Red is SQR, that's this. So it says that if you have the measure of angle PQS plus the measure of angle SQR, the blue region plus the red region, that gives us the measure of angle PQR. All it states is that we have one angle plus another angle would give us the big angle. So one of the inside angles plus the other inside angle gives us the big angle. It's just like the segment addition postulate. Notice what I did here in parentheses. Later on, you're going to have to use this as an explanation on why you're doing something in a proof. You can write down this entire thing, or anytime you see the word angle, you write an angle. Addition postulate. Abbreviations are going to be your best friend. So this is how you would abbreviate the angle addition postulate. Example number 3. The measure of angle ABD is equal to 37 degrees, and the measure of angle ABC is 84 degrees. Find the measure of angle DBC. If you have a picture, write it down. Label it. I cannot stress that enough. Label, 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 label. Fill in pictures. It will help you immensely. So the measure of angle ABD, this angle right here, is 37 degrees. The measure of angle ABC, the entire angle, is 84 degrees. We want to find the measure of angle DBC, which is this one. So this is just common sense now. This is 37. This piece we don't know. The entire thing is 84. So what would you do? You'd subtract them. 84 minus 37. So we know the measure of angle DBC is equal to 47 degrees. Notice how I wrote that. Very specific. We're talking about measurement, so the measure of angle DBC is equal to 47 degrees. I just realized that this example here should be 2, so I'm going to cross that off and put 2. Our next vocab word. An angle bisector is a ray that divides an angle into 2 congruent pieces. So for example, let me draw an angle. So I have angle, let's call this LJM. There's our angle. I'm going to say that we have a ray JK. Ray JK, this is important. Ray JK would be the angle bisector. So ray JK bisects angle LJM. Therefore, what do we know? If we know that this is a bisector, we know these two pieces are congruent. Therefore, we could say the measure of angle LJK would be equal to the measure of angle KJM, which is what I've let be true using these arc marks. Because the measurements are equal, we can say angle LJK is congruent to angle KJM. Once again, notice that here I'm talking about measurements. Measurements talk about numbers which are equal. These are the actual angles. Angles will be congruent. The next section are constructing the bisectors, which we have to use a compass for, which we can't do on the iPad. Our last example, example number 3. Ray BD bisects angle ABC. The measure of angle ABD is 6x plus 3, and the measure of angle DBC is equal to 8x minus 7 degrees. Find the measure of angle ABD. Once again, draw your diagram and label it. Always label. So if I have my picture, we know that ABD, this angle right in here, is 6x plus 3. We know that DBC, which is this angle, is 8x minus 7. So what can you do? This piece of information tells us what to do. We know that ray BD bisects it. If we have an angle bisector, what does that do to each of these pieces? It cuts them in half. So it cuts the big angle in half. Therefore, each of these pieces are what? They're congruent. So we know that those two angles are equal. So 6x plus 3 equals 8x minus 7. I want you to solve that yourself. Pause the video and solve it. If you did it, we can move the 6x over. We can move the minus 7 over. Divide by 2. X equals 5. And that looks really bad. Let's erase that. Now, if x equals 5, I'm still not done. I have to find the measure of angle ABD. So I can plug the 5 in. And that means the measure of angle ABD equals 33 degrees. And here are a list of the vocabulary and the postulates that you learned out of this section.